Hello and welcome to another episode of Ken's Training. Today's training, what we're going to do is we're going to just practice some brazing here. We actually are not in the middle of a job. We just wanted to give a brazing demonstration. I've got my oxyacetylene set up right here. I've already adjusted my flame, so that's good to go. Basically, I'm running about 7 pounds on the acetylene to about 15 pounds on the oxygen. I think this is a number 4 tip, but I'm not sure what the actual tip is on this one. Now what the braze is going to be is I'm going to simply put these caps onto this here, and I'm also going to braze this on to here as well. So I'm going to do those 3 brazes there. This here is a Schrader valve. And if this was an actual system and you wanted to tap into there and you wanted to hook up your manifold gauges, this would be a way that you could do it. So the first thing I'm going to do is I'm going to take the cap off. And this particular cap is a really nice cap, but right on the opposite side it has the Schrader valve removal tool built right in, so I don't even need to get out my secondary tool. So basically you just put that down in here. And there you go. There's your Schrader valve insert itself. So now, see if you can see that. There, you should be able to see right through that, like there. So you can see that it's going directly through. You don't want to have this inside, because if you do have this inside, it has rubbers and seats and things of this nature. So when you put the heat on it, you could potentially melt these particular seats, which you don't want to do. So I'm just going to set these aside. I don't require those. This is good to go. Now for the cleaning of the copper, basically I just took some standard aluminum oxide cloth, referred to as emery cloth, and I went through and just did even though it's new copper, brand new copper, went through and cleaned up the ends. And also cleaned up inside here where I'm going to be attaching this Schrader valve attachment. Okay. Now for the caps, this is a cleaning tool for copper, 3/4 inch and 1/2 inch. Right now I'm dealing with 1/2 inch copper, so just simply put it inside here like so, twist that up, and get that nice and clean on the inside. Also, I like to be wearing safety glasses whenever I'm working with solder. Even cleaning the solder, this way if a flake of metal was to brush into my eye or something like that, I want to be protected. So those are the steps that I'm going to take. Okay, so now that I've got this all clean, I also need to clean up the end right here where that's going to go. Alright, so that's all clean there. That one's ready to go. I'll take this here. And I'll just push this inside just to clean out inside of these caps here, so that those caps are ready. And then for this metal, it's basically like this. And I'll just lay that on its side. The brazing rod that I'm going to be using is this rod right here. It's called Stay Silver 15, so it has 15% of the silver content. This is a good brazing rod when you're going copper to copper. Everything I'm doing right here is copper to copper. This can be used to go from copper to brass. If I was going to go from copper to brass, I would use this flux, which is Stay Silver Flux. A white flux. Let me open it up so you can see inside of it. It's like a white, kind of a pasty type material, but since I'm going copper to copper, it will not be necessary. And we'll be brazing in just a second. Alright, so the copper is clean. I am ready to start making my first connection. For the first connection, I'll just put this cap onto here. Simple braze right there. So I'm just going to push that on, put that here in my vise just to give that a little bit of a hold. Very gently on the vise. Just kind of hold it like that, just so it just doesn't move around on me. Okay. And I'm going to light off the torch. So first I'm going to introduce the red, which is the acetylene. Let me trim that down. I had a little too aggressive there. Oh, one other thing that I should note. I've got a bucket of water here, a couple of rags. I got a spray bottle of water ready to spray my joints if I want to cool them. I also have a fire extinguisher right back here if I'm ready to use it. And as far as the oxygen tank, I'm going to keep that over here. I don't want that too close to where I'm going to be actually using it, so it's got a little bit of a distance. So I'll bring that over here because I don't need that at all. My adjustments are all set. I make all my adjustments right here in my wand, or my handle, my torch handle. And then I also put down some sheet metal here because I'm working off of a wood table surface. So so if I've got something hot, I can put it right here on top of that and not have to worry about anything burning up here. So I've taken all these precautions necessary. Okay, so here we go. Again, I'm going to introduce the acetylene first. Alright, put my flame right about like that where I see some feathering, a little bit of black, bring in some oxygen. Now I want to adjust my flame. Now that's not a bad flame right there. The cone is directly inside. That's actually pretty good. I'm going to just make my first attempt to see if that flame is hot enough in order to do this. Basically, I want to heat up the tube section first, so I'm going to heat that up, kind of moving this around. I'm not putting the blue cone on the copper. I'm off of that, so it's just the flame in front of it that I'm using there. And I'm going to heat the tube, and then I'm going to move that over to the cap. And I got to watch myself here that I'm not going to push the cap off. All right. And then I'm testing here with my rod, and now it's starting to flow. And I like to use if I can, I want to try to use the solder on the opposite side there. I'm pushing the heat, the Stay Silver 15, the brazing metal is going to follow the heat. So if I want it to go that way, I'm going to push the heat, pull the heat that way, braze on this side so it pulls in towards the heat. Constantly trying to work. I don't want the flame to go towards my body. I want it to go away from me. So just being careful about how I do that. All right. And get here on the bottom. Alright, so there's the first joint. And let me just wipe that down a little bit there. See how hot that is? I'm just hitting that with the spray gun. I don't want to quench it too fast, so I'm just quenching it kind of slowly. Okay. Now, let's see if I can't show you what that first joint looks like on there. So what I'm doing now is I'm inspecting the joint because I want to see what kind of coverage that I have. In case I'm still hot, I'm still just kind of protecting myself here with the holding it by the rag. I'm going to see if I can't show you really precisely what I'm looking at there. So right here on this section, right there, that is excellent how that looks. As I go around the joint, do you notice how it looks? I can still see that there's solder in there, but it's just not as pretty, I should say, as this section right here. I know that's a really good section. This cap is probably fine, but ideally what you're looking for, if you can get that type of a look all the way around circular, that is the ideal ideal filler material, soldering material, or brazing material rather, that you want to what you want your joint to look like. But that's one joint right there. Okay, so let's move on. Okay, so right now we're going to weld this Schrader valve tap onto here, right onto this half-inch copper tube. So to create that hole, I'm going to concentrate my heat going down, and I'm going to utilize it like that. Alright, so let me get my glasses on. I'm going to get my heat going. Start the torch up. Okay, right about there. That looks like a good flame. I'm going to now concentrate that heat. I'm actually wanting to create a hole right there. Okay, there it goes. Okay, right about there. Alright. Now that I recall, I haven't done this particular joint in a long time. I actually need to create the hole large enough to actually push this and depress this in slightly, and this is the reason why I'm not getting it. So what I'm going to do, let's see here. What I'm going to do is I'm going to heat this up in order to push out this hole a little bit. So that's going to be the first thing I'm going to do. Let me see if I can't get this in there. I want the hole to be as small as possible for what it is that I'm trying to accomplish here. That's why I didn't want that cap on there, because if I'd have put that cap on there, I probably might have a hard time with this, trying to do this. Alright. Pretty close. Very close right now. Okay, I'm in. And I'm actually in a little bit too aggressive. Went in a little bit tighter than what I wanted it to go. I don't want to be in that much. Pull that out a little bit. I guess if you were working blind, it'd be smart to measure that with the tape measure first so you know exactly how much you're sticking in the pipe. Okay, that's good. I'm sticking down the pipe about 1/8 of an inch. So now that I know that it's not going to fall and wobble on me, I'm in the pipe 1/8 of an inch. I'm going to go ahead and go back to my brazing. I should be able to get it now because it's not going to tip over on me. It's actually in there. Okay, so far so good. Come over here this way. Okay, looking real good. Okay. Okay, that looks really good. Let me shut that down. Get that over here. Throw on some clear glasses for a second. I'm just going to cool that joint down. Okay, I'm going to go ahead and hold that, and I'm just going to go ahead and quench that whole thing. And that's reasonably cold. Now I can show you that joint without getting burned. Okay, here you go. You can see, I'm going to go all the way around the joint for you so that you can see that, but you can see that I've got good coverage all the way around this joint. And I'm going to try to do this so you can see what it looks like inside. Can you see that? How much that's sticking out? How's that? Is it picking up at all?
Yeah, it's just there.
Right there? Alright, so that's just to show you how much. It's about 1/8 of an inch. And you see that I've got good coverage all the way around. Mind you, when you heat metal like the way that I'm doing it, you are weakening the metal. The copper is being weakened. We are going to do a pressure test on this. Once I put this last cap on, we're going to do a pressure test on this to see what it's going to do. So I'm going to put the last cap on right now. This should be pretty easy. So here we go. If I wanted to, I could just give myself a little bit of emery cloth right there. I already know that that this cap is clean. Okay, that's on. That's ready to go. And I'm just going to bring this over here, put this in here, and get that fairly tight. And here we go with our last joint. Bring your acetylene down so you start seeing some feathering. A little bit of black smoke's okay. There. That's the flame I like right there. That's what I'm looking for. That looks like a good flame to me. Now I'm going to go ahead and heat that up, starting with the tube. And we're going to push that out. Now mind you, if there's any heat that comes in here and there's pressure from the temperature from this, it'll now vent out here. This is why I didn't want to cap the system. This is the reason why I wanted the second joint to be that and not two caps. Alright, so I'm going to heat this up and I'm going to put the torch in my left hand and put the brazing rod in my right. See that venting out right there? That's the reason why I wanted that on before the second cap. If you'd have tried to put the second cap on and you'd have done it this way, you would have kept popping the cap off. Okay, but now there's a place for it to vent. Alright, we're heating up nicely. Everything's getting nice and hot. I'm going to see if I can't get this exactly the way I want it to look. Alright, moving the heat. This is really getting cherry red hot if you can see that in the camera. Okay, heating right there. I want to go underneath. I want to hit all aspects of the joint. Now the solder will naturally flow to the bottom anyways, but I just want to see. That's actually looking real good. I'm pretty satisfied with that. Kill the green, kill the oxygen, then kill the acetylene. Put this over here on my sheet metal. And I'm going to go ahead and quench that joint down with my water. Everything got pretty hot here. It's just a small piece of copper, so there's not, the heat's only going to go so far. Copper transfers heat really good. I'm going to go ahead, hold this up here at the brass fitting, and then quench the whole thing. Okay. Get that nice and good. And we are completely good there. Now, let me show you the joint that I just did, which is this joint. This is a really good joint. That's how the first one should have looked. See how that looks? You can see there's soldering, brazing rod all the way around. Now, in comparison, you see that one there doesn't quite look as pretty. So I used a little bit more brazing rod on this cap right here as opposed to this cap right here. Although I still feel pretty confident that the first cap that I did is still a fine braze. If this was a field joint, I'd retouch that and it would look identical to that before I would move forward. So that's basically brazing in a nutshell. We're going to do a pressure test here with nitrogen, and we're going to see how well this joint takes with, I think we'll juice this puppy up to about 600 psi, which is it's a nice pressure test to verify that all the joints that I did are going to hold. And we will stay tuned. We're going to show you that in the next segment. Okay, we are getting ready to perform our pressure test on the small little brazing test piece that we did. I'm going to leave the Schrader valve insert out because I don't want this to be pressurized. I'm just going to, after the test, I just want it to be depressurized. We are going to be using this tank, which is filled with compressed nitrogen. I haven't turned it on yet, but here, let me open that up. Okay, so the pressure in the tank is about 1800 psi. I haven't started to use my regulator yet. I'm going to use this charging hose right here, which I just pulled off of my manifold gauges. Now the charging hose has got a couple of pressures on it. It says that the charging hose 2,500 psi minimum burst, and then there's a dot, and then it says 500 psi maximum WP. So I'm assuming that what that means is the working pressure is 500 psi, but this will actually burst at 2,500 psi. So for the pressure test, we'll stay below both of these pressures. The pressure on the regulator will allow me to go all the way up to 600. 500 is right at that mark. So what I'll do is I'll go to about 480 psi if I can, as the test. So we're gonna do that. So here I go. I'm going to go onto the regulator of the nitrogen. And let me just put my safety glasses on here so I've got a little level of safety for myself. Alright, so I'm going to put those on, and let me get this on. Okay, so that's on right there. Now, I'm going to attach this here to the brand new Schrader valve tap that I just installed. Put that on about hand tight. Okay. Now, what I'm going to do is I just took this gray cart and I just laid it on its side. I'm going to take this and just put that over there. So when I'm juicing this up, if this thing was to perform a problem, it's not going to explode down on me. I'm not facing these gauges towards me, I'm kind of facing them away. But I want you as the camera audience to see that. Alright, so what I'm going to do is I'm going to turn in the pressure of the regulator. Now this is the pressure being exerted on the test piece. There's no vent there, so it's not venting out. Now if I wanted to see, like right there is 100 pounds. If I shut this valve, if there was a leak, that would come down. Plus, I don't hear anything. Another thing that I could do is I could just leave it at 100 pounds. Okay, here it is right here. And take my bucket of water. Now, can you zoom down on the bucket of water there? Now, here we are. I got 100 pounds on the system. And now we're looking for bubbles. And there is no bubbles there at all. So at 100 pounds, there's not even a pinhole of a leak in this system. We have nothing going on. So again, just to be a little safe, I'm going to put that over here so that if something were to be a catastrophe, it would blow up behind me and not come right at me. Okay, we're going to go up to 200 pounds. Nothing. Still quiet. I don't hear a thing. I'm going to jack it up to 300. I'm losing. Oh, I got to open up my nitrogen. I had my nitrogen on. Okay. And there's 300 pounds right there. Everything is still quiet. I'm going to go ahead and put that in the bucket. No bubbles, no nothing. 300 pounds on the system and nothing. But let's keep going. Because if this was an actual HVAC system, theoretically the condensing section could get up to, if there was a problem, let's say you had the condenser fan failure, the condenser fan was to fail. I've seen systems go up to 450 psi. So we definitely want to bring it up to 450. Alright, so we're cranking in on that. We're at 400 right there. And we're almost at 450. We're about 460 pounds right there. And I'd like to go to 480. That's 480 pounds. I don't want to push it too close to 500 because that's what the hose is rated at. but there's 480 pounds on my test piece. All my wells are good. I'll put that in the bucket, see if there's any bubbles. Can you go ahead and show that? You'll see that there's no bubbles. You can see the regulator. Can you see the regulator on that? Yes? Okay, so as you can see, I got 480 pounds. All that brazing that I did, the demonstration, is holding at this pressure. So I'm going to conclude the test. I'm going to close off on my nitrogen tank, relax on my spring, and I need to bleed the pressure off. The only thing I can do is crack this right here. There we go. Let me get that pressure off of here. Okay, you can see that dropping down. And we are back at a 0 psi state. So we are back to a safe condition. And there you go. So that was it. I just wanted to give you that demonstration so that, you know, even though I like the looks of the second cap that I did, and I explained why, I felt pretty confident that the first cap was going to be good, and indeed it was. 480 pounds right here on that cap, on this whole system right here that I did, and with that brazing of the Schrader valve tap, you saw that whole thing right there. So this whole thing can take 480 pounds of pressure, and it's would hold up in the field too. So thank you for watching.